You'd think one brilliant AI is a genius, right? Well, what about a whole team of them? Turns out that can be a total disaster. Today, we're going to dive into one of the biggest, trickiest challenges in AI, getting them to actually work together.
Okay, so picture this. You've got this dream team of super smart, specialized AI agents, right? You've got your architect AI, a traffic expert, one for utilities, the works. And you give them a simple one-line command. Hey, go build a city. What do you get? A perfectly tuned, futuristic metropolis, or just complete and utter digital chaos?
Well, let me tell you, without a clear set of rules for how they're supposed to talk to each other, you get chaos. Absolute chaos. I mean, the architect AI might design this beautiful skyscraper right where the utility AI is trying to lay a massive water main. See the problem? Each agent, working totally on its own, could be doing brilliant work that just completely cancels out what everyone else is doing. Individual genius it just isn't enough here.
So what's the solution? You got to give them a rule book, a shared language they can all understand. Let's break down how these AI agents actually talk to each other.
Okay, the official term is inter-agent communication, which sounds super technical, I know. But just think of it as a special language built just for AIs. It's this structured system that lets one agent send a message to another and know, for sure, that it's going to be understood, trusted, and acted on. This is the secret sauce that turns a mob of brilliant but separate AIs into a real, coordinated, effective team.
So let's pop the hood and see what one of these AI messages actually looks like. Each one is basically like a super secure tracked package. You've got a unique ID to keep track of the whole conversation, right? Then there's an expiration time, which is crucial because you don't want an AI using old, irrelevant info. And of course, tons of security checks to make sure the message is authentic and nobody's messed with it.
All right, so we know AIs need to talk, but how do you organize the whole conversation? I mean, who's in charge? It really boils down to two main models, which you can think of as the boss versus the team.
First up, you've got the hierarchy model. This is your classic top-down org chart. You have one boss agent that calls the shots and hands out tasks to the others. It's super efficient, really fast, especially when you have a clear plan you just need to execute. Then, on the other side, you have the democracy model. In this setup, all the agents are equals. They have to communicate, negotiate, and basically vote to come to a consensus. Think of it like a big cooperative brainstorming session. This approach is amazing for innovation and tackling complex problems where there isn't one obvious right answer.
But here's the thing. Neither model is perfect. Not by a long shot. Each one has a critical built-in weakness. With the hierarchy, the problem is a single point of failure, right? If that boss agent goes down, the whole system can just collapse. Game over. Now, with the democracy, the big risk is what you could call coordination chaos. The agents can get stuck in an endless debate loop, arguing forever without getting anything done. It's that classic trade-off, isn't it? Top-down control versus collaborative, but sometimes messy, resilience.
So, if we can figure out how to navigate these trade-offs, what's the big prize? What's the payoff? Well, it's absolutely staggering. We're talking about moving beyond just automating single tasks to potentially automating entire worlds.
And this really shows you the sheer scale of the ambition here. People are building prototypes for systems that could run an entire company. We're talking about AI agents handling everything from the nitty-gritty of supply chains to high-level marketing strategy. Or, hey, think even bigger, a network of AIs managing a whole smart city in real time. Imagine them coordinating traffic, the power grid, emergency services, all of it in perfect automated harmony. It's mind-blowing stuff.
But, and this is a big but, that amazing vision is still a long way off. The gap between a cool concept and a real-world system that can actually scale is just immense. We're talking about the absolute cutting edge of research here, and we are definitely not there yet.
And this brings us to the final, really high-stakes trade-off. Because when you're talking about this kind of unprecedented power, it comes with an equally unprecedented level of complexity and risk.
So you might be sitting there thinking, wow, with all these insane challenges, why even bother, right? What is the one killer feature, the single biggest advantage, that makes trying to tame all this complexity actually worthwhile? It all comes down to this one concept: fault isolation. Okay, think about it. In a system with thousands, maybe millions of moving parts, when something inevitably goes wrong, you have the ability to pinpoint exactly which agent is the culprit. It's like finding a single faulty wire in a computer the size of a city. That level of diagnostic precision, man, that is the holy grail for developers. But, and this is a huge but,
The price you paid to get that kind of precision is just astronomical. The complexity doesn't just add up, it multiplies on itself. Just look at this cascade of challenges you run into. The operational complexity is just extreme. Debugging becomes this massive, nightmarish undertaking. The individual agents themselves can get totally overloaded with too much information, too much context. And just trying to track what every single agent is doing at any given moment, that becomes a monumental task in itself.
Which leaves us with this huge, fundamental question. We have the potential for this incredible power, this fully automated world, but it comes bundled with the risk of overwhelming, maybe even unmanageable complexity. So is that dream worth the price? That is the massive challenge that AI researchers are wrestling with right now, and honestly, the jury is still out.